I wanted to say, sort of first up, while I've been sitting there, I've been thinking, Defra and policy members always say, we need this, and as a scientist, we always say, yeah, we can do that, and I'm a field scientist, and I think, yeah, we can do it with field science, and I know the EO scientists think we can do it with EO science, and the citizen science, we can do it with citizen science, and I think that we always want to be able to do what we do best, but we really do, it's really a learning process to see actually what are the best ways of monitoring for particular ends, where do those things work best in different situations, and I'll cover that a bit here. And also I would say that scientists, we're always catching up with policy, and we're still doing it. Policy wants integrated social, environmental, economic monitoring, and that's really hard. I do that, but it's not easy, and I think we need to be honest about the limitations of our science at the moment as well. Okay, so this, what I'm talking about is a UKEOF and Defra strategic agreement, a partnership called the Memorandum of Agreement. And did I go too quick? Okay, so the research partnership recognises UKCEH's role in collecting really important national scale monitoring data under its National Capability Programme, and it recognises Defra's need for that kind of data, and the agreement facilitates increased sharing of data between both of us. I mean, Defra and Natural England collect data too, they have skills data modelers, and it's about working together and enabling Defra to identify the elements which are really important and relevant to government policy, and allowing Defra to make funding available which can supplement the monitoring that we're doing in CEH. So the partners from the Defra side of things are Defra, UKCEH, well, UKCEH aren't for the Defra side, but Natural England as well. But you can see there the Defra programmes that are involved, so particularly the Environmental Analysis Unit, but also beyond that, future farming, there's future land use modelling as part of this, there's air quality work, you've already heard from Christine about that, and there's wildlife. So there are real needs across policy for the kind of monitoring that we do. So that's going to be too small probably to see, sorry about that, but this is just a breakdown of some of the tasks. The ones that are greyed out don't mean that they're not important, they're just not things I'm going to talk about today. But the other ones that I am going to talk about are around integrated monitoring at a range of spatial scales, satellite-based land cover and habitat monitoring, and indicator development for the 25-year environment plan. And all of them actually are relevant to that 25-year environment plan. And it's just about some very specific bits of work that we've been doing. Those of you who know me won't be at all surprised that I put that up. I worked on countryside survey for a very long time. It's a really important central tenet of our monitoring at CEH. We've done surveys over the long term from 78 to 07, and we've recently initiated a rolling programme in 2019. It's a randomly stratified sample of the type that Pete talked about being easy to analyse. It was designed for that very purpose, and it's quite a complex survey, has been in the past. So you'll see there's a number of red crosses up there. That's because those elements of the survey are not being carried forward at the moment. So the 25-year plan needs to be monitored. CEH is funding its own monitoring under UKEOF programme, that's our National Capability Programme. And we are funding just one aspect of CS going forward, and that is the randomly placed large vegetation plots. There are 5 of these in each of the 1 kilometre squares. We used to map them in their entirety in terms of habitats and landscape features. We used to also do headwater stream monitoring. Interesting that Rich said that the Environment Agency are now doing that. Maybe that will be able to take the place of what we used to do. And pond monitoring. We also did soil, macrofauna and invertebrates in streams, and soil profiles have been part of the survey as well. So there are elements that are not going forward just because they cost money, essentially. But we are going to the squares, we are going out there. So the question, I think one of the questions is, if we are going out there, that's one of the big expenses, you know, is it better to do more monitoring, or are there other ways of doing that monitoring? And this is one of the big questions we've been asked through the MOA. Do Earth observation and citizen science have something to offer us to fill those gaps in professional survey that are left? Do we need that extra monitoring anyway? And what will be the cost effectiveness of those approaches? We have to, you know, this is really something to think about. We're going out and doing those squares. Is it better to do a bit more when we're there, or are there ways of using EO data or citizen science? As we know, those are not free, those methods of collecting data. They involve a lot of people work as well. Okay, so these are the main questions that I'm going to talk about. I don't need to go into detail, they're just to show you there are 6 areas. So I'm going to go through these next 6 areas and those questions. So it'll be a bit like jumping about, which is why I thought I'd put the lot up so that you don't lose the thread. Okay. So the first one, so this is about delivering indicators for the 25-year environment plan. What data is going to be needed and how can it most efficiently be collected? So can we use EO data for the national estimation of habitat extent, as has been done with CS? So the mapping data used to be converted into national estimates of habitat cover. So we know that Land Cover Map, the Earth Observed data, provides data on habitat extent. It's a coarser resolution than field survey, and measuring change has proved a bit difficult. Although, note, there is a Land Cover change map coming out quite soon. The likelihood is that that will be at an even coarser level than Land Cover Map can be produced, because actually it's the technology moves on so quickly in this area that looking at change over time is quite a difficult process. So we're having a look at, if we don't go out and map the squares, what can we do? So we go to 5 locations in the squares and record plots in those. Can we use EO data, which lines up with those plots, because they're quite big plots, they're 200 metre squares, they're the size of a pixel. Can we then use that data to give us some estimates of habitat in those squares and of habitat change? You know, as you can see from there, it's going to miss quite a few of the habitats. It's going to miss some of the smaller ones. It's going to miss some of the bigger ones as well, but we need to just look at that and see what we can get out of that and how useful that will be. So another area we've been looking at is, can we use Lidar data to collect data on linear features? There's a lot of talk about this. This is the way to do it. I think they're being used in living maps and things like that. So we have looked at the Lidar data, and we can use Lidar data. It is coarser than field collected data, but it can give us it at a whole national scale. But it's an extent of woody features and some aspects of condition. So we've had a look. Lidar data, how much is there available, temporally and spatially? How do you make the data into linear features? It doesn't come as a linear feature data set, it comes as a point cloud data set. You then have to interpret it and process it so that you can get it into lines. And can we line it up with field boundaries? So there were 591 squares in 2007. 8 of them had full Lidar for 2007. The Lidar relationship with the linears is pretty good, but that's not very many squares, as you'd appreciate. That would be really useful data, because if we are going to go forward with Lidar, we needed to be able to ground truth that data well with the CS data so that we could say something about it. There's a table there on there's a grand total of 291 which we thought we could get Lidar data for. Actually, in 69 of their squares there was actually no Lidar present. And in 137 we got quite a good alignment. So it's patchy. That's likely to change going forward. Lidar data is likely to get better. There might be more complete coverages available. But it's something we really have to look at closely. And one of the things about the linear feature data is that it's very detailed. In the last survey, it's incredibly detailed. We looked at height, you look at many aspects of condition, probably 30 variables collected per hedge. And that's actually very difficult to get back from Lidar. You might be able to get the height and the width, but you can't get many other aspects of condition. And for CS data, which was one of the things that drove the hedgerow regulations, which stopped basically hedgerows being removed in England, it begs the question of, is this kind of data going to give us the power to do that, have that kind of influence on policy? So here's some pictures of the Lidar data. Because the light's not very good, you can't actually see the lines, but if you could see the lines, you'd notice that the Lidar lies very well aligned with the RPA data. So we could use the RPA data to extrapolate the Lidar data. The CS data is less well aligned, but we've never thought that mattered too much as long as we got the right lengths in the field. But what the key questions we're now approaching are, can we differentiate between when it's a line of trees and when it's a managed hedge? We've so far looked about 75% accuracy where we've got the Lidar data. And then we've got to look at elements of condition and consider whether Lidar can be used to look at change. Okay, this is an example of using some of the MPMS data which you've heard about as a counterfactual for agri-environment schemes. So agri-environment schemes, we need to know what the background, what's happening in the background, so that we can compare to what's happened under the schemes. So with HLS monitoring, CS data was used as baseline because it was around at the same time, 2007, because we didn't have any more CS data come 2016-17, we thought we would use the MPMS data. And we had a look at that. So we looked at change between CS and MPMS across that time period and change within HLS. But we did find some real issues with the MPMS data. It showed a bias towards higher quality patches, which isn't very surprising because the squares are weighted towards higher quality patches. And it also tends to be on publicly accessible land and on easy accessible locations. So that locational bias meant we couldn't actually do that comparison. So this is where, you've got to think which is the best data for the job. And in that case, the MPMS wasn't. Some of the other areas of work, I've got a countryside survey and the ECN in red there because they're both quite diminished in terms of their vegetation data. In fact, there's none going forward in the environmental change network. So while we can do this analysis for past data, we don't really know what we're going to be able to do going forward because we might not have this data. We do have the National Plant Monitoring Scheme and the Long-Term Monitoring Network data. But we're compiling all that data, trying to get it together, and we'll be looking at producing indicator modelling work, which helps us to produce a model of change for each indicator and single estimate across all the different data sets. You definitely can't see those figures. You can see the numbers of plots, but they differ quite a lot. The MPMS at the top of that diagram on the left is the proportion of plots, the large area at the bottom, CS, the sort of medium size is ECN. So there are real differences between these surveys in the numbers of plots covered. That will change going forward, but these are issues we have to think about. Finally, two other areas we've been looking at indicators. We've been looking at producing landscape character indicators and with Natural England, and this has been using a whole series of data sets, land cover map and a lot of external data sets like DTMs, digital terrain models and road networks, Natural England's tranquility data, and you can see all the different variables. So they've been put together into a map. That's the white peak, which shows you an index of landscape character from high to low. So that's one of the other areas of work we're developing with Natural England, inputting, telling us what they think is important from their landscape staff. And finally, this has been a really challenging one, is to try and develop indicators of habitat quality. This is under the habitat quality, quantity and connectivity indicator. And we're trying to get consensus. What is habitat quality? What data sets should we be using? So we've looked at all the measures which are commonly done by Natural England and Defra and others, and we've started to come up with lists of potential indicators that we can use going forward. And they might be the same indicators for different habitats. So how nutrient rich the plants, how responsive plants are to nutrient richness, and that might be the same for 5 or 6 different habitats. We're also looking at landscape level indicators like habitat heterogeneity. So we're working on that one. We've had workshops, and yeah, that's a tough one to nut to crack.